There we go.
Alright. Rolling.
Yes.
Okay. Basically what I have here is a coil gun, so to speak, to propel a magnetic BB using only electromagnetic forces, magnetic fields. So what I start off with is I have a circuit board, a flash circuit from out of a disposable camera. Added a few things, removed what it came with, added a battery holder. What I have over here on the proto board is actually 3 capacitors, 300 volt capacitors, each one from a disposable flash camera, but I only have one circuit. What this does, adding 3 capacitors in parallel, basically increases the capacitance, and when it discharges through the circuit and then through the coil over here, just provides more voltage, makes a greater magnetic field, propels the BB at a faster rate. So what happens is, put the battery in. If you listen close, you can hear it start charging. Now what we're going to have to do is wait for this little green light right back here to light up, and once that green light lights up, the circuit's charged. What I did to make the coil is I have, it's called transformer wire. It's an insulated wire, and it's wrapped around a non-conductive plastic tube. There's 10 layers of coil with probably about 20 wraps a piece. This coil is basically what's going to create the magnetic field. Inside of the plastic tube I have a brass tube, which the brass is kind of irrelevant. You can use kind of whatever you want in there, but it just so happens that that brass tube is the perfect size for one of these little BBs. The BB is a copper-clad zinc BB. In the inside, it's magnetic, which it has to be, so it would be attracted to the magnetic field. Take the BB, place it inside the tube. The little green light is on, indicating that these 3 capacitors are all fully charged. So I line that up with the deck of cards like so. I hit the button here, and yeah, probably couldn't see it, but it did shoot out and hit the deck of cards. So it's recharging again. Basically, again, what happens, the voltage comes through the wire, the voltage goes through all those coils hundreds and hundreds of times in an instant, creating a magnetic field right in the center of that coil. The BB is behind the coil, therefore when that magnetic field is charged up, that BB moves towards it really, really fast. It only happens for an instant and then stops, therefore the BB just continues on out the tube. The light is back on again. Let's take another BB, load the tube there, and fire.
It went a lot better that time.
Nice, nice. When I'm done with the circuit, I have to remove the battery so it doesn't charge again. However, it automatically charges, so there's a certain amount that gets charged. I have to discharge it here. The capacitors, I measured them earlier. The capacitors, even after discharging the final time, hold about 50 volts. You always want to make sure when dealing with capacitors to go ahead and short out the circuit. Ooh. I jump every time. It doesn't matter. To make sure that you don't get zapped. And there you go.